Hello again, everybody. Hopefully everybody enjoyed the lunch. Pretty tasty stuff. We are now ready to go with part 2 of our Spark Ohio pitch competition. If you weren't here yesterday, it is a Shark Tank-like competition. Young entrepreneur students pitch their ideas. They're evaluated, they're questioned, and they will be judged. And the winner will be presented at tomorrow's lunch. And the winner gets a $5,000 award toward their startup or their idea. So without further ado, I'll turn it over to Rick to take over and give you a little more information on it and bring up our first presenter.
Thank you, Jim. If you were here yesterday, you know how we go through this. Everybody should have about a 10-minute pitch and then 5 minutes for questions from the panel of judges here. Our judges, starting on my right, are Ron Chicker, Mindy Barrel, and Jing Lyon. So thank you, judges, for your participation and being here today. So the first presentation, I'm going to go in alphabetical order by name of company, and the first presentation will be from Aptos Orbital, and the presenter will be Simon Halpern.
Just leave the show. Is it okay? Test, test. Hi, thanks everybody for coming. Thank you to the judges and the sponsors. My name's Simon Halpern, and I am one of the co-founders of Aptos Orbital. And at Aptos,
If you want to walk around it,
thank you. We are working on connecting satellites to the cloud. Let's see if this works here. There we go. So I want to just take a step back and maybe think about your phone as something that's constantly connected to the internet. If you think about how the internet is built, it's built around persistent connectivity. It's built around powerful compute, and it's built around the cloud to be able to distribute and access data from around the world easily. So that's the internet as we know it today. That's what's on our phones and in our pockets. Unfortunately, satellites don't live in that world. Satellites don't really have an IP address, so to speak. We're specifically focused on low Earth orbit. So when I'm talking about connectivity, I'm talking about the fact that a satellite in low Earth orbit is typically talks to the ground once every few hours. There's sort of rudimentary compute on board, although that's getting better. And the satellite itself is siloed from the cloud. All the data comes down raw from the satellite, and then it gets distributed into the cloud and processed. So the place we wanted to enter the market was within the connectivity side of that three-part equation. So if you look at the cost of owning and operating a satellite, say 5 years in low Earth orbit, you're going to spend a ton of money. Most of it is going to be on connecting to that satellite. You're going to be paying ground station operators or satellite operators in your company to stay connected to the satellite and bring that data down and maybe send up data as well. So we want to connect space to the cloud. We want to start by connecting it through a proprietary RF data network. These are two of our products right here, the Max and the Mini. We use a proprietary data network, a third-party satellite constellation. You all are probably familiar with the Iridium network, so that's one of the networks that we leverage to provide pole-to-pole coverage, so no more pointing or pass planning to worry about. We also stuck an edge computer inside, so that high-speed compute can be right next to the data that's collected, and you can process that data in real time. What we mean by that is you're not necessarily interested in an image the size of this screen here that's got a picture of the ocean. What you're interested in probably is the latitude and longitude of two ships in the ocean and where they're going and why. And then we actually provide cloud services. So using cloud services that are standard on Earth, they're now available on board our system. And we have 3 of these in space today. The longest one's been in space about 2 years. And so I want to talk a little bit more about the connectivity that we provide. You're probably familiar with ground stations connecting once every couple of orbits. You've got to point your satellite, and then you can connect, download a bunch of data, then start processing it. Just had a nice talk with a couple of gentlemen about space lasers. Lasers are super cool. A lot of data you can get down, but very hard to point two lasers at each other in LEO and get that system working, especially if you're on a CubeSat or a smaller satellite. The laser can probably cost more than the entire spacecraft, at least in today's world. There are some options. You can go out to GEO. You've got a longer latency to deal with. You've got limited connectivity at the poles. Super expensive systems. And so our system, our Mini and our Max, they connect anywhere pole to pole as long as you are lower than Iridium. Iridium sits at 780 kilometers. So the majority of satellites in LEO are probably more like 450 to 600 kilometers. It's a small system. That's it. There's no second box. There's a big box and a small box depending on the satellite. No pointing required. Our software intelligently chooses which antenna and which Iridium spacecraft to talk to. And there is no cost to the hardware. I'll explain how that works in a minute. These are a list of some of our customers today. We have about 10 commercial customers representing about 10 launches in the next year. The colonel from the Space Force earlier mentioned he sees space as in space, to space, and from space. So I guess you could segment ours as this situational awareness. That's what's going on in space. That's how we segment customers doing rendezvous proximity operations. From space, Earth observation, right, getting insights from space. We don't do rockets, but so the to space would be on the bus providers would be more like around space. Anybody who wants a persistent link to their spacecraft, whether it's commercial, civil, or defense oriented, you can maintain a link to your satellite at any time, and these companies build constellations for other companies. The unit, back to the business model, no CapEx required. It's a subscription, same as your cell phone. You go to Verizon or T-Mobile, you pay for a plan where you get a certain volume of data per month. Same thing with us. You tell us how much data you want to use in a given month, and we hand you the hardware, sign the contract, off we go. These systems are rated for 5 years in low Earth orbit, and we, Chirag, sorry, we went with AWS, but we still use Azure if you want, but we're actually certified by AWS, so you can run AWS native workloads in space. And right now we're sitting on around $1 million of booked revenue. So that would be, I guess, on the 2025 there. That's in terminal sales. That's the connectivity portion of our business. We're looking to win government contracts. So right now we're a sub on some Space Force contracts, and as well as contracted directly with NASA, JPL. Hoping to expand those over the years. And then the data partnerships are where it gets interesting. I mentioned we use an edge computer on board. So companies like IBM that built Watson X or Deloitte, which has built a cybersecurity solution for space called Silent Shield, can be run as third-party applications on board our system. This is the team. I myself was at Northrop for about 10 years as a systems engineer, satellite operator. I then left, started a company that focused on high altitude balloons as a service, sold that to Apple in 2015, started a couple other companies that have subsequently been sold. Amir comes from the cybersecurity world, so he makes our system as developer friendly as possible. Customers love what he has done. We just got a nice note from a customer that said, your ICD is amazing, it just worked. So that's Amir. And Yonatan, you may have heard of Space IL. If you haven't heard of Space IL, you probably heard of the first commercial lunar lander. Yonatan founded that company, designed, built, launched, and crash landed the world's first commercial lunar lander. But they say every startup likes to make an impact, so that's what he's done. And he's actually a bit of a trendsetter because, as you may know, a lot of other companies are now crashing into the moon. So we've got a great team. And since this is supposed to be Shark Tank-like, we're raising $1 million seed round. We're currently a little bit oversubscribed, but we're happy to take additional checks. That's going to extend our runway, give us time to start taking our commercial contracts, turning them into scaled contracts. So we just signed a deal with a customer where if our pilot works out, they'll buy up to 100 additional units. And then, of course, go after the government world, including both certifying the unit for government security levels, as well as building out the government accounting system and all the fun stuff you need to to do if you want to work with Uncle Sam. And I have to mention this. I went to Michigan, so this is a tough room just to. Hey, thank you. All right. I've heard Ohio a lot today, but Ohio is actually one of the 3 finalists that we're looking at to when we go to scale for production, as well as some of the additional testing we want to do. The facilities here are obviously world class, so we'd be very interested in chatting with anyone who was interested. We're looking at EMI testing and all the usual spacecraft testing you have to do for our systems. And with that, this is my email and our website. If you want to reach out, you want to buy something, you want to buy stock, you want to buy a unit, or you just have questions, please feel free to reach out. Thank you.
Thank you, Simon. Is this working? Yes.
Yes.
Thank you, Simon. I'll turn this over to our judges to see if they have any questions.
You mentioned that there are already 3 units out there, and you've got 10 more customers to deploy over the next 12 months. What are the biggest risk factors?
Let's see. Probably from a business standpoint, it's launch slips and the fact that we're a venture-funded startup. So that's we don't have control over Elon's schedule. That's one of the biggest risks. The other is the way that the customer intends to use the system versus maybe how we want them to use it. And the delta there is if they're limited on power or they can't perfectly place the unit, they may have a limited field of view. So we advertise great connectivity, but if you put the unit facing Nader, you're not going to get any connectivity. So as we're learning, we're just making sure customers are planning to use the unit in the right way. That's probably the biggest risk for now.
Hi. Your orbit is 780, I think it said?
Iridium operates at 780.
Okay. What or do you operate at?
So we sell the subscription with the free box, and the customers operate between as low as 250 kilometers in VLEO all the way up to 650.
What I was going to get at is 700. A lot of government customers, you're talking to really government customers, a lot of them operate between, say, 700 and 833, 850 sort of kilometers. That's kind of tough for Iridium to connect to. How do you do that? And how many satellites do you really need to get the kind of connectivity you really need?
Good question. And you will start to experience gaps in Iridium coverage, even with the side lobes above like 700 or so. We have a customer doing a geosynchronous transfer, so we're going to see exactly where you really lose coverage with them. But in the meantime, the other way we're looking at addressing that problem is by getting enough of these systems out there that these systems can actually talk to each other, as long as they're within a reasonable distance of a couple thousand kilometers. So in that case, you're talking about like a mesh network. And so I mentioned we need to have a few hundred satellites out there to have ubiquitous coverage at those altitudes. But by the end of the decade, that's our hope, is that we can get up to those and start to talk to additional constellation owners about filling in the gaps with Iridium.
Go ahead.
What do you see as your biggest bottleneck to scale?
I mentioned manufacturing. I think that's a solvable problem. So the biggest bottleneck might be the fact that RF is not a laser. And so how do we get speeds up to something that people can say, you know what, I was thinking about a laser and this is fine, megabit, 10 megabits a second. That I think is a physics problem and an RF problem that we have to really focus on.
Okay, and you mentioned some of the technology is proprietary. Is it protected by patents? Could somebody pick this up and reverse engineer it?
We're taking a little bit of, there's a little more secret sauce in it. We don't have any patents. It's a little bit like, this is maybe an unfair analogy, but the little Tesla-like. I mean, electric motors exist, the internet exists, car chassis exist, you put them all together. So what we've done is heavily modified, and we have a partnership with Iridium So we can modify the systems and get them licensed. You have to get a companion license if you want to operate this in space. So we work with the Iridium Office of the CTO to mitigate the problem, the IP problem that way, and just trying to get, land and expand is our strategy to just make this the system of choice.
All right, I think time is up for questions, unless you have one more, Ron?
One more.
Okay.
I mean, it's a lot happening in the space communications and edge computing and AI sort of realm. Who do you see as your competitors, and how that whole system evolving? And how do you really? What's your real competitive advantage over how do you differentiate?
There's a great question. There's within Edge. There's a lot of folks just working on edge compute, both people just building the computers as well as companies like Loft that have the full spacecraft and the compute on board. The advantage we're trying to bring is that it's not just about the compute, but it's about deploying code, just like you would over the cloud. So in the same way that you could talk to an IoT device on Earth, you want to be able to talk to your spacecraft. So that experience of being able to easily deploy code through AWS and make your satellite more like an IP address is where we're trying to focus. I'll pause there. I think the other side of that coin is that's a little bit up to the folks writing the AI algorithms or the workloads. So they may want to run on something specific. They may need to be connected to certain sensors. And so we just have to keep an eye out for the folks actually writing the code as opposed to us providing the infrastructure. So thank you.
All right, that was the final question. Thank you very much, Simon.
Thank you.
Our next presenter is John Vickers of Blue Abyss. He's jogging up.
Thank you, everybody. I just want to acknowledge that if you don't remember anything else, we were introduced as young. Anyway, so John Vickers, the company is Blue Abyss. We're starting a new company. It's called Blue Abyss XG to stand for Extreme Gravity. I don't think it really should stand for Extreme Gravity, but that was the brand name we went with. A parabolic flight, what they used to call the Vomit Comet. I get told off for calling it that, but that's probably what most of the older people in the room, so not me, will remember. Anyway, I'm the chief executive of the overall company, Blue Abyss Global Holdings. We're planning to build a centre here in Cleveland and a centre in the UK, and the idea is to expand from there. Blue Abyss XG sits under, for the moment, the North American company, the centre we're building in Cleveland. Was this the clicker? Yes. Thank you. So I changed the slide and then didn't give the very kind gentleman at the back the slide that I changed. So rather than a problem, we see it as a challenge. You're here in a space conference. You will hear undoubtedly lots about technology. I've been in love with space since about 1975 when I watched the Apollo-Soyuz link-up. It's always about the technology. I make it a sort of parallel that we talk about lots of airplanes, lots of airports, but nobody's talking about the ground crew, the pilots, the crew, the passengers. We're as a company focused on the people element of going into space. You can put as many satellites up there as you want. You can talk about as many destinations. We can crash into as many bodies up there as we can, but really the thing for us as a species, I think, is for us to eventually go. As such, space offers two things. The opportunity as a naturally curious species for us to go into space, for us to expand and explore. Potentially lots of people tell us that our future as a species is off this planet. But also, convincingly, the other way, there's lots of terrestrial benefit from what we can learn and adapt from the extreme environment we find in space, those things that we can adapt for here on Earth. So Velcro is a typical example that people cite, and Tempur mattresses, but there's lots of innovation. Medical, new pharmaceuticals, new metals, all of that stuff that can be developed off this planet for benefit on this planet. I think the opportunity to change the paradigm of how we've been using and viewing space. So commercially, satellites fully well established, commercial launch fully well established. But the president has suggested that we want to send people outwards from this planet and eventually, successful or not, towards Mars. So here's the solution as we see it. We've positioned ourselves really as a picks and shovels company. So we're about doing the very basic stuff. I see the exploration companies and satellites companies as those who are actually going to dig for the gold. But to dig for gold, you need picks and shovels and pairs of jeans. If you don't understand, if I was to ask everybody in this audience, I suspect a fair large majority would stick their hand up and say, I'd love to go into space. But are you suitable for going into space? NASA's recent selection process took 20,000 US applicants and finally selected 10 of them. Now that's not a commercial future. I think we're at that stage where we're at an inflection point, a shift in paradigm, where it is going to open to mass participation. And so we want to be able to help that mass participation. You don't want to be one of 10 people vying to get into space. You want to be hundreds of people knowing you're going. So Blue Abyss, just a very quick overview. The Cleveland Center at the back gate of NASA Glenn, out by the airport. We've got the 13 acres. We cleared it with the Amish. So 21st century, 17th century, a few months ago, cleared the biggest trees. We're intending to start building, clearing the rest of the site before winter sets in, and then it's about an 18-month build process. But in order to complement the aquatic centre, which is used for a marine as well as a space focus, we're also looking to build the long-arm human centrifuge there, and the bit I'm talking to you today about, the parabolic flight, next generation capability. What does that mean? Why? Well, if you look at the historical number of people going to space, it didn't really count. But the future of space will go from the few, maybe even the tens, to the hundreds, to, I expect, perhaps even quicker than this slide demonstrates, to the thousands of people. There doesn't exist a pipeline today to enable that to happen. Our competitors in the parabolic space flight business, they have got planes in Europe that are 35 years old, one plane, and in the US, 727, which is now 40 plus years old. I think there is an opportunity to bring new modernity, including technology, with a wide-bodied, more efficient plane to offer a better, more reliable and regular service. That dynamic about how many space stations there are, 5 to 7, I don't know what the other nations are potentially planning. Obviously, most of the focus remains, rightfully so, here in the US. We're already talking about 3, 4, possibly 5, some of them completely privately funded. But there is no pipeline at the moment being developed for who the audience are that will use those. Space market is already huge. We were at an event yesterday, we were talking about, over $500 billion. In the next sort of 5, 6, 7 years, it's reckoned to be a $1.5 trillion space economy globally. We want to continue that. We want the American market to be the hub of that innovation and largesse. But if you don't start factoring in the people part, it won't be American boots getting to the moon first. It won't be that you can come to the US and get on an American rocket and go to a destination like a low Earth orbit hotel, etc. There is a competitive analysis. There are only really two main competitors. That's Zero G, who operate the 727 in the US at the moment, and Novaspace, who operate an older Airbus plane in Europe. Both have suffered a little bit. 727s tend to be difficult to maintain. There's a declining population of pilots who are certified to fly them. By bringing in a new 757 wide-body jet, in fact, I think it might even be a 767 as the airframe we looked at recently, with a freighter aperture, we don't need to compromise experiments that are coming on board. We don't need to break them down into smaller bits to fit them in the plane. We can take more people at a lower cost per seat. The planes are more efficient. We're using new technology on a newer plane to ensure that the parabolas we fly are more accurate. And we can give that experience to a wider range of astronauts, scientists, filmmakers, general members of the public. You'll notice I'm not on this slide. I don't take a good photo besides not being, I'm young. But a world-class team to lead a new world-class business. So senior executives, former Rolls-Royce, who were involved in aircraft, one of the world's foremost parabolic flight experts, Professor Vladimir Pletzer, over 1,500 parabolas. He holds a world record for the number of individual different types of plane flown. Pilots, people with extensive sales and marketing experience in the US space sector, and the knowledge to be able to put all of that together, and as well as run the company, develop this software to enable us to fly more accurate parabolas. I should have just said you saw how that was nested. Blue Abyss XG is nested under Blue Abyss Operations and Blue Abyss Global Holdings, of which I'm the chief executive, but for the moment I'm helping set up the US. So we've already got $50 million worth of LOIs. That was without a plane. Planes are a bit notorious. If you're trying to lease a plane in this case rather than buy an airframe, you have to have the money available right at that time and then to secure the airframe. We've taken a slightly different pragmatic approach, built the pipeline. We can already see that in 3 years' time that pipeline will have trebled, and there is a 10-year study that we've been conducting with NASA and with other partners to understand what the human potential is for going into space, as well as the scientific need for services like this. This is one of those funky financial slides that just makes, I think, everybody go to sleep normally. Revenue, you'll see that in all of the 3 slides, the first year is nothing. That's because in identifying an airframe, we need to spend about a year modifying it. All planes are certified, modern jets are certified to do parabolas, parabolic flight, but it's the ability to do sustained parabolic flights that we need to adapt some of the pumps and systems to ensure that the plane didn't just finish a dive and carry on going, for instance. You get some reusability and it comes back up. By the end of it, we're projecting a second aircraft by year 3, 4 to handle the European market. One plane can fly between different destinations. They've been doing that in the US with Zero G for a number of years. But the ability to have a second plane and look after our European customers was felt to be important. And you see that in the third slide, the EBITDA. So it's about a 38% profitable business. So that's fairly high for a return on investment and a service-led business like this, where you've got something that normally it's cram as many people onto a seat as possible, fly them to a destination, get them off, put more people on and fly them back. This is a different model based on the size of the plane and the quality of what we're doing. Just to summarise, before I say thank you very much for all your time and listening, we're at a new paradigm for people going into space. I get very passionate about not just technology. Technology for technology's sake is wonderful, but I don't know how many other phones I can carry around. We've assembled a world-class team to look at the opportunity to say, how do we go from the few to the many? One of the things that you need to do is, it doesn't matter how many people stick their hand up, we need to know who's capable of going, have we prepared them properly, can we train them, and make sure that they come back safely. That's what we've done. We've looked at making this a pragmatic, scalable, secure business financially with a long-term future. So thank you very much indeed for listening. Hope you enjoy the rest of your day. Thank you.
My battery's running low. Okay, I guess we'll open it up for questions from the judges.
I think you sort of alluded to this, but I actually have 2 questions in here. That's somewhat related. You talked about your neutral buoyancy tank, your aquatic center.
Yes.
And you talked about the parabolic flights and some of your competitors, but that's a whole. And you talked about your market being parabolic flights, but there's a much broader thing here of access to low gravity in general. And how do you really fit within that food chain? That structure here, you mentioned you had one of the slides that showed Blue Origin and the suborbital flights. Where do you really fit within that? Are you working with them? Do you see them as collaborators? Do you see them as collaborative part of this food chain? Do you see them as competitors? Where do you really fit in that? And along the same lines, you get the kind of who are your customers for the parabolic flights?
Yep.
And how do you acquire those? How do you get to the kind of numbers you need to make it really a mass thing?
So the first part of the question first, we're also working with NASA Glenn. NASA Glenn has a drop tower at the moment. It was built in the 1960s. A drop tower is, as the name suggests, a tower that you drop things down. Happens to be a vacuum chamber, effectively. The one at NASA Glenn is about 512 feet deep, built in the 1960s. And effectively you drop what looks like a child's rendition of a rocket upside down into, at the very bottom, there is a pit, a 30-foot pit of polystyrene balls. So if you ever wonder where all the polystyrene in the world goes to, It's a drop tower in NASA Glen. The opportunity to create a modern version of that was something that we've been working with NASA Glen on. So there is a continuum. You don't just go into low Earth orbit. You wouldn't just send somebody scuba diving at night into a wreck 300 feet deep. You'd expect them to gradually build up that. The same is true if you're going to do a science experiment or send somebody into space. You can't use the drop towers for people. Potentially you could, but it's never been done. It's not probably an ideal scenario. But for us, from a parabolic flight and an experimental point of view, so using a bigger, wider plane that you can do different, newer things in, the plane is secure, the plane's more efficient, the plane flies an accurate parabola. In other words, you're increasing the likelihood that the experiment, if it's going to work, produces the results you were expecting. That's one part. So parabolic flight builds on drop towers. So we see that as part of the continuum. Someone like Virgin Galactic or Blue Origin then has the next stage. They go slightly higher. In Virgin Galactic's case, the flight would take slightly longer, so you'd get more opportunity to experience low gravity scenarios. So we see ourselves as being at the very base, that infrastructure layer again, and then building on that and then handing that off. If a customer feels that after a series of parabolic flights, or normally a campaign. So a campaign is a program where a customer with an experiment says, right, I want to do X number of flights. I want to, each after a series of flights, a flight might have 20 or 30 parabolas in it. After that, you might say, right, I want to adjust something in order to run that campaign again and improve something. We see ourselves as being at the end of that, where a customer can say, I've done all the testing I need, I'm prepared to take the financial risk of sending this experiment, tool, piece of equipment into space. But there is absolutely an argument for saying if you could extend that amount, so 0G, the amount of time that you were in free fall, if you want to experience zero gravity, it's about 20 seconds. Lunar gravity, it's about 25. Martian gravity in a parabolic flight, the profiles are slightly different, it's about 30 seconds. Doing 4.5 minutes with Virgin Galactic is obviously a demonstrable step change, and we see that as a logical argument from going from a drop tower to parabolic flight to something like Virgin Galactic or Blue Origin, and then into low Earth orbit. The other side, so I think, when I did a random survey yesterday, something like 60% of the audience put their hand up. If I asked who would like to go into space, genuinely thought I'd love to go into space. No? A few hands. There's not as adventurous an audience. I need a more adventurous audience. So I think globally, this aspiration that going into space and the driver that people like Elon Musk suggest that humanity face, that we need to go into space, suggests that there is broadly across the population a number of people who would like to at least experience what it would be like to go into space. So that audience doesn't have to go into space. It's difficult, it's expensive, it's very challenging. Most astronauts don't fail because they're not fit or not clever. They fail on their psychological resilience to stress. If you can build up the continuum of training slowly and incrementally, but using technology, I didn't mention that, for instance, inside the plane, augmented and mixed reality. Not perhaps on your very first trip, that might be a bit much, but the next time you go, if you're actually donning a spacesuit and around you, you can see blackness and the moon or the earth below you, that sense of realism, I think, heightens the opportunity for us to create a phenomenal, visceral training experience. And for the members of the public who aren't former test pilots, etc., who may have shorter windows of time to do training, that's important.
Okay,
very long answer, sorry.
Oh, that's all right. Time for one more question.
Who are these customers, and if there's such a demand out there, why hasn't one of the larger organizations done this?
That's a very good question. So Zero G have, for the last sort of 20-odd plus years, been focused on the US market. Novaspace have cornered the European market effectively. We see that there has been less focus on the humans. Absolutely. There has been less focus on humans going. But when we worked with, in order to generate that pipeline of $50 million, we worked with spaceports, we worked with international clients, we worked with events like this to say, if this was an additional feature of that event, would people be interested? And that's where we generated the amount of information, most of the information we've got. The other was going to speak to some of those customers that you've mentioned. Some you might see them as competitors, and to see what the science opportunity was. Science pays more money, and as I mentioned, before you send something into space and find it doesn't work, the opportunity to do an amount of pragmatic, cost-effective training and iteration development, TRL, technology readiness level, That was where we went and focused our attention. That's what the 10-year study that I mentioned briefly was also focused on. We're waiting to publish that shortly.
Okay, thank you. Thank you, John.
Thank you very much indeed. Thank you, everybody.
All right, let's see. Our next pitch will come from Abhishek Chopra of BQP. I see John getting high fives back there.
Hello everyone, myself Abhi Chopra. I'm the founder and CEO of BQP. BQP is a Syracuse-based seed state startup. We are accelerating modeling and simulation with quantum computing but without quantum computers today for mission critical industries. I'm an aerospace engineer and a computational scientist by trade. Developed large-scale modeling simulation codes for computational fluid dynamics on Fortran 77 and C, believe it or not, taking 6 months on 250,000 computers. This was to understand, for example, turbulence behind the tail of an aircraft. This is not what industry wants. Industry has to perform, let's say, 10,000 scenarios for each component. So this is very prohibitive, and I wanted to solve this problem of slow and expensive simulations. I worked with Oak Ridge National Lab and NVIDIA to basically bring these simulations from CPUs to GPUs with the hope that we will get acceleration in the speed. But unfortunately, we got zero speed up, actually worse performance even on the largest supercomputer of the world. And the reason for that is because the compute has always been there. The challenge is the math that goes behind these tools are just outdated and haven't changed in past 40 years. So that's really the problem I focused on and started BQP with my co-founder, who you saw in my previous slide. And eventually, when we start to get more throughput and utilize the compute power that we have today, we'll realize, especially with the advent of AI now and Gen AI, we are talking about compute being the problem, which will be the case. So your future data center will have a CPU, a GPU, and a quantum computer sitting next to each other. So how do you solve that problem? It's a big challenge in the modeling simulation world. The numbers look big, but they are just representing the problems that can be solved today. There's a report by ANSYS and AWS which says that 78% of modeling simulation problems in the industry just cannot be solved today, which is not represented in this number, by the way. So this mismatch between the outdated math, which is basically algorithms, and the compute lead to engineers always choosing between time and accuracy. So you can either go towards doing simulations which are fast, but they're inaccurate, or doing which is opposite, you're slow and expensive. And that's where we build our company, where what we are building is, we like to call it the BlackRock of the simulation world. So what we really mean by that is we are building a back-end engine which plugs into your existing workflows and your existing tools and supercharges it. So the input doesn't change, the output doesn't change, the infrastructure you're using today does not change. You can do 10 times more simulation as a simulation engineer in 1 hour than you were able to do before. So what will actually change is your coffee breaks will get shorter, is how I like to put it. So in this world where the modeling simulation is, there's the companies we recognize. So on the right-hand side of my side, these are using the old and outdated math. And then you have a whole world which is building this quantum softwares, which actually they are waiting for quantum computers to come in. And that's where we have carved out a niche where we're utilizing the field of quantum information science, where the math has always been laid out, that preceded the field of quantum computing. And we are utilizing that math on existing hardware and giving that 1 order of performance improvement. Here's an example of what Airbus did with us. They challenged us with this problem of the wing design, which is a very critical part of an aircraft. What we did compared to their tool was the process remained the same, but we got to a wing design which was more lightweight by 6%, which represent $3,000 fuel cost per flight. What that means is basically their customer, which is the airline industry, can save that much on fuel cost. But not only that, what it means for Airbus is that we got there in 1/10 of the time. That means they can now perform those 10,000 design scenarios, which was not possible before, getting to their final design much faster. And here in this case, we estimated a reduction by about a year or two, saving them about $1.5 to $2 billion. Airbus was just a start. We have taken this to many of the primes and tier 1, tier 2 manufacturers, including IAI North America. We are doing a lot of good work with Air Force Research Lab in Wright-Patterson, which I'm very proud to say that, which is on aircraft vehicle design, And then with Navy with NAVSEA, where we are looking at electromagnetic spectrum monitoring with machine learning. We are looking at space domain awareness at SDA TAP Lab, where we are looking at uncorrelated track processing. These are just examples of those problems that were prohibitive before, which we are enabling with more throughput on current compute. We are starting from direct sales, but we are going towards this back-end engine, the BlackRock vision that we have laid out for ourselves, where we have already started the integration. So that's our second go-to-market, where we are already integrated, for example, with MathWorks. So it's as simple as you going to MATLAB, downloading our toolbox, calling it A is equal to, let's say you're using genetic algorithm, removing that, calling BQ5 QIO, input remains the same, output remains the same, and you can start using our tool with such a low lift. So aerospace defense is just the start. We have a broader engineering industry, and then beyond engineering, there's biotech, finance, and other industries that we cannot think of today where this kind of compute is required. This company is built by 3 co-founders, myself and my other co-founder, tech co-founder that you saw, but also our COO, who's coming from quantitative finance. We have folks who have done enterprise sales. We have a former major sergeant from Air Force, who's our VP of strategic growth, who's basically leading the government efforts. And then we have folks from the simulation industries who have been there, done that many, many times, and now they're doing this next paradigm of things. We are proud to announce that we have closed our $5 million seed round. There's strategic investments that are coming in from some of these customers that we have. So that's where we are raising the additional $800K for those strategic customers. The reason why I'm also here, and when we submitted the pitch, and thanks to the organizers here, it gave me the opportunity to come to this audience, which is, I believe, very much focused on the technical side of, and also representing the customers. We are looking for both government partners to work with us and under CRADA, for example, how we're working with AFRL RQ, but also with academia and partners where we can build things together and demonstrate this capability. Thank you so much, and I'm happy to take any questions.
I guess I'll ask the first one. You mentioned that it's algorithms and computing power. Computing power, it looked like quantum computing, which I know is just a developing field. Then there's AI. Mm-hmm. And my son actually is in Silicon Valley. He's an AI engineer. He writes software. He tells me that, I assume that's where your algorithms come from, software. He tells me that in the future, all the software is going to be written by AI, so you really won't need software engineers like you do today, which is his job, which is why he's so aware of it. Are you factoring that in to your business? Is that like a fundamental AI, using AI for the algorithm development?
No, this is actually, we are going to core mathematics and rewriting the solvers from scratch. And then there's a part of software piece, which is relatively easy. Like if you see our team configuration, the smallest team we have is the software team. But the algorithm, the core, going into the weeds of how stochastic algorithms from quantum information science come about, implementing this efficiently on, let's say, a GPU or a CPU, and then eventually quantum computers. Then you go on to the third stage, where you basically implement for real world, like class of problems, so optimization, machine learning, AI. You have partial differential equation like computational fluid dynamics. And then the fourth layer comes in where how can you give the user that experience which is so low lift that they can utilize it. The software piece in this is the last, you can say, the fourth layer, but there's the first three pieces which we have to essentially rethink going back to 80s and do it.
Thank you. Any other questions from the judges?
A lot of these type of computational, once somebody proves it's possible, somebody else is probably going to try to beat you. So how do you keep your market stake?
I think it's time is what I say the real essence. I think technology always runs fast, but it's about getting to the customers and customer utilizing it. And this is a very sticky product. So once you are there, I mean, the tools have stayed over 40 years. We are just getting started. And that, I think, so is the key moat here. And it's for engineers, many times you might have the greatest technology saying that, oh, I can run CFD on a GPU. It's not what customers want, either from a pricing point of view, from an implementation point of view. They don't want to go to a new tool for doing that. And that's where being a simulation engineer myself, we realize these kind of challenges and penetrating the market an unorthodox way, then it's usually done from what we have seen. And then partnering with the existing folks. So that gives us a lot of leverage. It gives a huge market, even as a young startup.
As you look to grow and expand, how are you assessing or hiring the type of business development talent you're going to need, right? This isn't an engineer with a cool new toy saying, I'm going to just design a new widget or piece or part, right? How you define mission critical may mean different things to the engineering team from what it might from the team responsible for the P&L or the ROI of the investment. So how are you training your team to go in and uncover like the next project and the next opportunity after that?
So today we are finding those patterns through our own business development team. So that's where you see people who, like our VP of strategic growth, our VP of business, they have done this sort of with enterprise sales and commercial and in defense world. Moving forward, we don't want to be building that sales team ourselves because it's a lot of cost, it's a lot of time consumption. That's where we want to rely on channel sales partner. So for example, with MathWorks, that's where they are very much interested in supporting their customers through this quantum technology, and they being able to find something so easy. It's like their sales team wants to push them rather than our sales team. So our thought process as we go towards a Series A is people who have these kind of channel partners type of experience rather than domain expertise, because we can never build enough domain expertise for the kind of industries we want to tap. It's a huge market for us then.
Okay, time for one more question.
So I don't understand how you're monetizing this. The subscription. Do you sell them the front-end processor in here? Do you sell them the algorithms here? Do you license things? What's a monetization strategy?
Very simple. It's basically licensing our platform. So the solvers comes with that. Now they can go through, like I mentioned, existing partners like MathWorks or Ansys, or they can directly buy through us. The way we have brought in a slight innovation in terms of even the pricing, because that's more acceptable to, for example, folks at Air Force Research Lab, NAVSEA and others that we've seen, is instead of giving them per user or giving them like per compute node, we are just giving them a block. So if your high performance computers can support up to like 100 cores, you are one block. Unlimited users, unlimited applications you can fit in, you pay that yearly license. Then you have the next year and the next year after that.
Okay, thank you very much, Abhishek.
Thank you.
And our final presentation will be from Kamel Green of Fibrex.
It's on.
Turn it off.
It's on. Yeah.
Yeah, you can use mine.
It's on.
It's almost dead. Oh, it's working.
Hello, my name is Kamel Green, founder and CEO of FiberX. I can distinctly remember while working for the National Nuclear Security Administration, there was this continuous emphasis on wanting to understand the structural health of our critical infrastructure. This is because when critical infrastructure is not adequately monitored, it can prove disastrous, ultimately leading to the loss of life, supply chain vulnerabilities, and national security openness. And so here at FiberX, we're building a solution that addresses corrosion and structural health monitoring. That is specifically within space in situ corrosion, which is on the NASA shortfall list. We are equipping our platform with both edge cloud computing, AI, as well as digital twin. So this allows our end user to be able to see structural health issues as well as corrosion prior to being able to see it with the naked eye. And so although structural health may not be as sexy as you've listened to many people come up and present, it's infrastructure. And so we are that layer that's not simply a nice to have, we're a necessity. And so here's the problem. We're addressing a $3.2 trillion market. And so when you look at corrosion and structural health, the reality is that there's a lot of inadequate solutions. We currently have a partially exclusive license with the US Navy. And the reason being is because when it comes to corrosion, there's no adequate solution. You have things like LiDAR, you have cathartic methods as well as sonar. However, the reality is those are monitoring change detections, not necessarily corrosion. And so when you look at the solutions in more detail, there's a lot of outdated methods and there's no adequate solution that thoroughly works for the quote unquote big guys. And so what we've built here at FiberX is we built a real-time structural health platform. This means this is utilizing fiber optic as the sensor itself. And so if you have infrastructure, we're able to epoxy those sensors on that infrastructure, ranging from a wide range of different use cases. So that's satellites, spaceships, offshore wind turbines, a whole heap of different applications. And so this is a full system that now the end user has a digital twin representation so they can see that problem and be more preemptive opposed to reactive. And so here's a more detail of how this solution actually works. If you see this right here, you see a commercial plane. However, you can look at this as multiple different platforms. Again, offshore wind turbine, oil and gas, et cetera. And so we multi-layer these fiber optics distributed amongst that platform itself. And then what we have next is we benchmark. And within benchmark, we look for strain phenomenons. So that means once it gets back to that initial state, if it is a lurking variable or there's something that does not get back to that original state, that's now a strain phenomenon, which is when we have signal interpretation, damage quantification, and then we wirelessly send that information to a digital twin where you see that data visualization. And so now you're not sitting back hoping for this critical infrastructure that goes to space or this critical infrastructure that allows for water, that allows for energy, et cetera, to have a problem. You can fix that problem before it happens. And so here's our traction. So again, as I've alluded to before, we have a partial exclusive license with the US Navy, which gives us exclusivity in 21 fields of use. We also have former partnerships with UC San Diego, where we're working specifically as our NAVSEA partner, where we're licensed with, and then addressing certain issues in partnership with UC San Diego. We also are working with IAI, so Israel Aerospace of North America. And then we're working on hypersonic testing with University of Arizona. And then we're doing some artificial intelligence testing with Bowie State. And then we're working with a small oil and gas company out in Utah. So again, what I like to denote is this is not a figment of my imagination. This is something that's serious and this is something that's here. As far as our market size, again, as you've heard me say before, it's a massive market. This is $3.2 trillion. But if I was to put on my VC hat, I'll say, how in the hell is this a $3.2 trillion market? The reason being is because of the multiple different use cases. You've heard presenters today, those are all use cases within those arenas. This is something that enables additional technology. So specifically how we're addressing that, because my VC hat it on again, would then say, well, where's your beachhead? Well, the reality is we're focused a dual use platform. So we have private and public use cases. Specifically within the public sector, that's aerospace and defense. Specifically in the private sector, that's oil and gas, as well as maritime, offshore wind turbines. And we're positioning ourselves well within those markets. As far as what is obtainable to us, what service obtainable market, that's a $45 billion market, which we are addressing and attacking, where we're establishing both our first mover advantage as well as defensible moat in the market. So here's our roadmap. Our plan right now is Q1 to Q2 of fiscal year 2026 to be at just over $1.2 million annual recurring revenue. And that is because our platform itself, we have great margins when addressing kind of the cost of our application, our product in itself, and what people are paying for. It looks fairly lucrative in that regard. How we get to that, however, is those partnerships that we talked about when it comes to R&D, hypersonic testing, utilizing these wind tunnels at University of Arizona, being strategic in how we can test, but also addressing the private markets as well, which is a lower sales cycle. And that's where we're hitting annual recurring revenue as far as 1.2 here in a little bit. How do we make money? So this is a platform as a service. I have a background I'm a two-time founder. My first company was also a dual-use application. And so I've had experience in selling to the government as well as working in the government. And what I've identified is a unique way on how we can sell to government to expedite those sales contracts, and that's platform as a service. So think of SaaS, but instead of it being software, it's a platform. Here's our team. Again, as I mentioned before, I have experience working for both Pacific Northwest National Laboratory as well as National Nuclear Security Administration, and I've raised a venture company prior to this. And so I use those skills of execution and strategy in this dual-use market. Carson, we both attended Brigham Young University together. He has skills when it comes to engineering. And then you see Tremaine and Julius, and we have a few other engineers that's not on here. But Tremaine and Julius, I like to denote because specifically what I've learned even more working in the deep tech application, there's a lot of analysis paralysis. There's a lot of we're hypothesizing on this, we're testing this, and there's a lot of slow to market. We're addressing that market. As I mentioned before, we're establishing that first mover advantage. So Tremaine and Julius' background in working in government, selling to government, as well as entrepreneurs themselves, are strategically pushing us and helping us get in position from a sales standpoint. And then as you can see, our affiliates, specifically our inventors out of NAVSEA as well, who's helping us. Here's our advisory board. Each member here on this board is strategically here to help position us in a different area of focus. You see Google, that's more from the private sector. You see Department of Defense, as well as Space Force, where we're specifically getting advisors to help leverage certain avenues within this whole multi-domain focus. As far as our ask, we're currently raising $1 million. It's looking fairly good. We just opened up our round. We're at about 70% of that right now. And so here today, open to any partnership opportunities as well as investment opportunities. But again here, and I conclude this with this, is that this is a solution that is actually addressing certain areas of focus within the market that a lot of people look past. But it's going to be a necessity for all these different technologies. So it's a massive opportunity, but it's a necessity as well. Thank you. My name is Kamel Green, and I'm excited for the question that you all have.
First question from the judges.
Yeah. You showed a slide with the fiber optic network in there, and I wanted to really understand what is it you're really providing. Are you providing the fiber optic network? Are you providing the integration of that system, of the sensors?
The fiber optic is a sensor itself, and so a lot of times people that preconceived notion of what traditionally fiber optics do, as far as communications, know that we're monitoring change in pressure as well as temperature. So the fiber optic is the sensor.
Yeah, I understand that, but are you providing that network into the aircraft? Are you doing that integration?
Yes.
Or that's something that's already there?
Yes. So there is, in certain applications, especially when it comes to composites, they do use sonar somewhat, and so it's using that same type of complex. We're just altering the sensor that's being used.
Not sure I understood your answer. You said you're using an existing fiber optic network and utilizing it differently, or are you installing and actually
There's
integrating?
existing use cases specifically in airplanes for sensor detection, right. And so we're not necessarily reinventing the wheel when it comes to utilizing our technology.
Okay.
Yep.
You have a very aggressive timeline. What does the actual customer funnel look like right now, the sales cycle and deployment cycle, to be able to get to that Q1 goal?
Yeah, so uniquely enough, because of the cost of our solution, if we're able to transition a few of our pilots to pay pilots, closing 2 deals will get us to $1.2 million. Right now, our current pipeline has about 10 different entities right now. And so the process is free pilot to paid pilot as of now, as we're starting off. But that's what's indicative of the timeline, what you see. And so the context is aggressive, obviously, but not in that regard, considering the fact of the cost of our solution.
Help me understand what's unique, like what IP you have protected, what's proprietary. Getting back to the earlier question, if you're integrating, that's a service and your expertise may be valuable, but help me understand sort of what's your special sauce
No,
here.
really good question. The special sauce is the patent. And so having a partially exclusive license with the U.S. Navy, who, one, is credible in the space, but two, because there was not an adequate solution when it came to maritime structural health and corrosion detection, this is why they invented that. We now have a partially exclusive license, which allows us for 21 fields of use with the U.S. Navy. So that's our defensibility within this space.
Time for one more question.
Yeah, can you talk a little bit about your customers in here, particularly not necessarily the Navy customers, but the infrastructure customers out to the maritime and other aerospace companies, and the equipment manufacturers, and so on. What kind of
Yes.
relationship do you have with them, and where are you with that inroads?
Yeah, a lot of times it's going to be manufacturing, but specifically maintenance. And so that's a wide range from offshore wind turbines to oil and gas customers. And so there's multiple different use cases. Again, how we've done it is we've positioned it for dual use. So we have a sales team for public, sales team for private. And so we're going after more specifically the point of contact is someone that's over maintenance within companies such as offshore, aerospace, and things like that.
Okay, thank you very much, Kamel. And that's our last presentation. I knew the battery was going. Okay, that is our final presentation. The judges have a lot of work to do to sort through all this.
So final presentation of the day. Judges have some to sort through all these presenters and decide on a winner to be presented tomorrow. So speaking of tomorrow, so that concludes today. If you are going on the tour of the Sears Think Box, please meet over at our registration desk over there in a few minutes, and we'll leave here by 2:15 for that. If you are going to the happy hour tonight, it's 6 p.m. at the Jolly Scholar, which is basically right behind us over here in another building. It is a ticketed event, but you can buy tickets at the door. And if you're wearing your registration badge, you'll get a discount. So we hope to see you there. And then tomorrow we start up again at 9 o'clock. We've got tech transfer, we've got radio isotope power systems, and we've got AI, and then a keynote from astronaut Doug Wheelock. So hopefully we'll see a lot of you tomorrow, and thanks for being here. Have a great day.